All right, so we have talked about shifting up, down, left, right. We have talked about vertical stretches and compressions, and we have talked about reflections. We're going to put that all together now and just enjoy using all the pieces together. Real quick reminder, what happened last time. Adding or subtracting k on the outside, or just adding or subtracting a number on the outside is going to move it up or down. Plus on the outside moves it up. Negative on the outside moves it down. If you have plus or minus inside the function, that's going to move you left or right. Minus is right, plus is left. If you have a number being multiplied on the outside of the function, that is going to either stretch your graph and make it skinnier, like this little pink graph right here. So those numbers right here, these are all bigger than 1, which is what stretches it. And then here, if we have a number that is less than 1, like 1/3, 2/5, 1/4, that's going to make it wider and fatter or shorter. Vertical reflections, those are a reflection over the x-axis. That's when a negative is out front. Here, reflection over the y-axis when there's a negative on the inside. So let's use all that and let's talk about it. So real quickly, very last page in here is a cheat sheet. It says all the things I just showed you. So this is all of the rules cheat sheet. These base graphs, you could go ahead and fill these in from your way back library of functions video. All right, these library of functions can be copied onto that cheat sheet. In fact, I'm going to pause and do that right now. All right, so I have filled in these graphs with some important points labeled on them. You can pause and copy it down. This is just from what we did the other day. More importantly, though, there's this information over here that talks about the order in which to do transformations. There's many right answers to this, but there's also many wrong answers. So we're going to stick with this. Left and right shifts first. Left and right first, then stretch and compress, then any reflections, then the up and down shift. So we're going to do these up and down shifts very, very last. Left, right, then stretch and compress, then any reflections, then up and down. All right, let's do it. So here, we have this function here, y equals absolute value of x minus 4 plus 2, and we want to graph it using transformations. The base function here is the absolute value of x. Okay. So we can take some key points from our absolute value function. Right. Right here. Oh, I forgot to label 0, 0. That's 0, 0. I'm going to take negative 1, 1, 1, 1, and 0, 0. And what are we doing to them? Well, we have a minus 4. Ooh, that's not what I wanted. We have a minus 4 on the inside. That's going to be a shift to the right by 4. Right 4. Here, oh man, I don't know why it's doing that. This plus 2 on the outside is going to be up 2. So we'll do our right shift first, and then we'll do our left shift. So my original point, negative 1, 1, right here. I want to move this guy. Well, I wonder if I can make this even better by, yeah. I can move this guy right 4, 1, 2, 3, 4, and then up 2, 1, 2. So this point, negative 1, 1, moved to the point 3, 3. the point 0, 0. Point 0, 0. Starts here. We're moving him to the right 4. 1, 2, 3, 4. And up 2. 1, 2. So he is moved to the point 4, 2. And finally, the point 1, 1. 1, 1. Moves right 4. 1, 2, 3, 4. And moves up 2. 1, 2. We know what an absolute value function looks like. It starts at its vertex and then has straight lines coming out in another direction. And there we go. That's our transformed function. Now I want to talk really quickly about what happened to each of these points at each part of the transformation. When we're going right 4 units, that's going to be the same as adding 4 to the x value. I'll just write plus 4 to x. So this changes the point from -1, 1. If you add 4 to -1, you get 3, 1. Here, 0 plus 4 is 4, 4, 0. 5, 1. The next step is moving up 2, which is adding 2 to the y value. So we're going to take our already translated to the right point and add 2 to its y value. 1 plus 2 is 3, so that gives us the point 3, 3, which is exactly where it ended up. It's at 3, 3. Adding 2 to the y value here, leave the x value alone, we have the point 4, 2, which is indeed where that point moved to. And finally, for this last one, we are moving the y value up 2. We have 5, 3. Sure enough, 5, 3. So that is sketching that graph using transformations. The left, right, up, down shifts, those tend to be a little easier to graph, but we can get a little more crazy here. Let's look at what's happening because there's a lot going on. I pause there for a sec. All right, so let's talk about this little chart I have here. What we're going to do to graph this guy is fill out a chart where we talk about the function notation and we talk about geometrically what's happening. For the function y equals -4 square root of x plus 2, the base graph is the square root of x. That is the base function. On the square root of x graph, we have a few important points. If you remember down here, 0, 0, 1, 1, 4, 2, and 9, 3. All right. On our list down at the bottom of the page, we have left and right shifts as happening first on the inside here. What color did I use for? I used pink for the inside. Might as well use it again. On the inside here, we have a +2. A +2 on the inside is going to mean we're going right 2. We're shifting the graph to the right 2. That's going to change our graph into the graph of x +2. Geometrically, going to the right 2 Oh, and I'm an idiot because this is left 2. Not that I'm an idiot. I didn't say that. That wasn't me that said that. I am tired. Left 2 plus is left. Left 2. So we're shifting the graph to the left 2. Geometrically, we're taking these same coordinate points and we are subtracting 2 off the x coordinate. So it's x minus 2, not 0, y. X minus 2. So when you shift to the left 2, it shows up as plus 2 on the inside of the function, but the actual transformation that you're doing is subtracting 2 off of the left, off of the x value. So on all of these, I'm going to subtract 2 on the x value. We are leaving the y value alone. All right. Next on our cheat sheet, we did the left-right stretches or compressions. So we have a number out front. We have the number 4 out front. I don't know why it's doing that. That's a little annoying. 4 is greater than 1, so it's going to be a stretch. This is a vertical stretch by a factor of 4. So when we shift these points around, we're going to be shifting them to this function, 4 times the square root of x plus 2. We're doing this one step at a time. What is happening here is we are taking these values from our first transformation and we are multiplying the y values by 4. So the x values will stay the same. The y values will be multiplied by 4. I am leaving all the x values the same from the previous column. 0 times 4 is 0. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. Finally, out front, there is a negative sign. My goodness, I don't know. That's so weird. Out front, there is a negative sign. Negative signs out front of the function is going to be a reflection over the x-axis. This is also known as a vertical reflection. This is going to give us that negative out front. Reflecting over the x-axis changes the sign on the y value. So our x value will stay the same. We're just going to make the y value negative from this previous step. Zero doesn't change sign. 4 changes to -4. 8 changes to -8. 12 changes to -12. Those are our new points. All right. So the original graph looks like this. Okay, that's the original. These points right here will be on our new graph that's been translated. This guy right down here, unfortunately, does not fit within our graphing area, so we won't be plotting that point, but we will be plotting these guys here. So we have -2, 0. We have -1, -4. We have 2, 8. 2, sorry, 2, -8. That's all we can do, and it's going to look like this. And so you might be thinking, like, that doesn't even look like the same graph. But let's think about what has happened here. This point 0, 0, it goes to the left twice. We multiply its y value by 4 and then make it negative. It stays the same. This point right here, go to the left 2. We're going to multiply its y value by 4. So instead of 1, it's going to go to 4. And then reflecting it over the x-axis, we want it to go all the way down to here. This point over here, left 2, multiply the y value by 4, and then flip it all the way down. This all checks out. Really what's happening is this is a much taller graph of the x squared function that's just going to kind of look like an x squared function after enough time. All right. Let's go ahead and do another one of these graphs. Here, our absolute value, we have y equals 2, absolute value x minus 3, parent graph, which I guess we've been calling the base graph. Base graph and parent graph mean the same thing. I'm going to leave it. Our base graph is the absolute value of x. We have two different transformations happening here. One is this guy out front. This is a vertical stretch by 2. This guy right here is shifting down by 3. It's -3 on the outside. If we go to our list of transformations and the order that they're supposed to be applied in, we should start with our vertical stretch. When we do that, that's just applying the 2 out front of our function, multiplying our y values by 2. For the absolute value of x, important points, -1, 1, 0, 0, 1, 1. Those are important points. Leaving the x values alone, multiplying y by 2. I'm then going to shift everything down 3, which will give us our final function, to absolute value of x minus 3. That's going to be subtracting 3 from our y values. So all of our x values will stay the same, and we will subtract 3 from each of these y values. 2 minus 3 is -1, 0 minus 3 is -3, 2 minus 3 is -1. All right. So this point, 0, 0, that is originally the vertex of our function, moves to the point 0, -3. Moves to the point 0, -3. Let me go ahead and plot it. The other 2 points move from -1, 1 to -1, -1. And the other one moves to 1, -1. This is the graph of 2 absolute value of x minus 3. The original absolute value graph, by the way, would have looked like this. Let's see. Oh man, I'm really bad at drawing those lines. Yeah, that's not quite it. There you go. So the absolute value, the original one would be the black one, and then you can see the purple one, the transformed one, skinnier and moved down 2 units. We can do this without a table. We don't need a table. We don't have to do it that way. By the way, there's this stuff down here. I might do that with it paused. I don't think I'm going to make the video doing that last problem. This guy here, what transformations do we have? There's a negative out front. That means that we are going to reflect over the x-axis. There's a +1 on the inside, which is to the left one. And there's a +2. That's annoying. +2 on the outside. That is going up 2. The order of our transformations, we're going to do left and right shifts first. So our first is our original function, y equals absolute value of x, the parent function. Next, we'll do the left shift. I'll write that up here, left 1, which will transform this function into y equals the absolute value of x plus 1. Next, we're going to do the reflection. Which will change this into the function y equals negative absolute value of x plus 1. And then finally, we will do the up 2, which will give us the function we were looking for, negative absolute value of x plus 1 plus 2. Our original absolute value of x we have drawn so many times that we might feel sick of it. Left 1. That means I'm taking my point that was at 0, 0 and moving it to the left 1. I'm going to take, it doesn't matter what, right? I could take this point -4, 4 and move it to the left 1. I could take this point right here. This is 5, 5. And I can move it. It was originally here. We're moving it to the left 1. So that is the graph just shifted to the left 1. We're now doing reflections. So we had the point -5. You know what I'm going to do? Duplicate. Here's what I'm going to do. Taking this point, if I'm reflecting him over the x-axis, that means that he is going to be 4 units away, but on the other side of the x-axis, 4 units away from the x-axis. So we go here, -4. For this guy, he's on the x-axis, so he doesn't reflect. For this point here, he is 5 units away from the x-axis, so we're going to go 5 units downward. Finally, we're taking this graph and we are shifting it up too. And, why don't I just do it like this? We have this, we go up 1, up 2. And there it is. This is what would happen if you took the absolute value of x and you shifted it to the left 1, reflected it, and then moved it up. So for this one right here, it's the kind of combination of this guy and the previous problems where you're taking points and you are transforming them. I am going to fill out some of it. Then I'm going to tell you that I'm going to pause the video. You should also pause the video, try it out, and unpause it to see the answer. So first of all, the base function here is x squared. That's because there's a square right there. The points that you should use for this function, we're going to do -4, not -4, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. All right, I want you to do just as we have before. You're going to write each of the transformations in the correct order. You're going to write geometrically what happens to the point, and then you're going to shift the points around, and this time graph them all right here. I'm going to pause and unpause regularly to show you the answers step by step, but I don't want to write it all out on camera. So pause the video now to work on it yourself. All right, for that first transformation, you should be going right to. Here are the different coordinate points. Here is the picture. I'm going to pause again and do our second transformation. All right, for your next step, you should be compressing by 1/2. That will be our next step here. When you compress by 1/2, you're going to multiply your y value by 1/2. So I took these coordinate points, I left the x alone, and I multiplied that x value with the y value by 1/2. That's going to give you a slightly wider looking parabola. All right, I'm going to go ahead and do transformation number 3. All right, so the next thing we're doing is taking care of the negative out front, which is a reflection over the x-axis. So we are multiplying our y values by -1, i.e. just flipping the sign on any y values we see. So I did that, and your graph is going to look a little like this. We're almost done. We have one last transformation, and that'll be it. All right, here is our final transformation. We are going down 1. That means we are subtracting 1 off the y value. So I took all these y values, I subtracted 1, and bam, there is our final function. So step by step, we started with the base, we moved it to the right 2, then we kind of we compressed it, so we made it wider. We took this picture and then we reflected it over the x-axis, and then we took it and we moved it down 1 unit, and bam, we got ourselves a beautiful, beautiful graph. So make sure that you have this filled out completely. You're going to want to reference this part right over here anyway, so print this off. You probably have because you're working on it right now. That is all on this section. I'm going to do one more video where I talk about just some like non-base graphs and how we deal with those. And then that'll be it. And then you'll know transformation. All right. Have a good day. I will see you in another video. Bye.